Hello and welcome to our Atelier office with your G4G team, Indra and Alex. On today's broadcast, we heard from amazing speakers on how innovative thinking can lead to new and very cool solutions. So the more information we have on the world around us, the better we can actually make those decisions and create innovative thinking. And to help us get there, math and statistics can reveal a lot about the world around us and will help make us the best choice possible. And so on today's experiment, we're going to learn all about probability.
Indeed, we're going to look at probabilities today. So what is the probability that your school bus will be late tomorrow? What's the probability that a pop star will cross your path? What is the probability of an earthquake occurring, of a rugby player injuring themselves during a game? Those are all important questions. So basically, life is a game of chance. It is a sequence or a chain of events that could either come true or not come true. But what we do know for sure is that math is a fantastic tool to help us make decisions. So let's say to increase our successes and to decrease our failures. So that probability basically tells us the likelihood that an event is going to come true. It is the chance of something happening or not happening. Are you ready to play a probability game? Yes! Very good, because we are actually going to explore today the math behind the well-known game rock, paper and scissors. We are going to see if calculating the probabilities of the game can actually help us beat the odds and win the game. Wouldn't we love to know what move our opponent or friend Alex is going to throw next? What are the chances that they're going to throw paper? What are the chances that they're not going to throw rock? So we are going to play the probability game today, calculate the probabilities, and see if this can help us answer some of those very important questions. All right, Alex. We have three strategies in this game: rock, paper, and scissors. So what conclusions do we draw from this? Each time we play a certain strategy, we can either win or lose, or indeed draw. But also, each strategy, rock, paper and scissors, has an equal chance of winning, an equal probability of winning. That is 1 out of 3.
But if they all have an equal probability, it doesn't look like there's a strategy to win. Or is there?
Alex, I'm going to play rock, paper and scissors together with you 20 times right now. We are friends, but today I will consider you my opponent because we want to know how to increase our winning chances against our opponents. So what we are going to do is we are going to count, in order to reach our probability calculation, how many times Alex will throw stone, how many times paper, and how many times scissors. And then we are going to calculate the chance, the probability of her throwing each strategy within the 20 rounds of game that we will play now. Ready?
Yes!
Alright, we are ready to take a look at the results of our game. We're going to see the probability, the chances that Alex threw a certain strategy or move within the game. The way we're going to do this is by first, we counted how many times did she throw each move. So, rock 8 times, paper was thrown 5 times, and scissors 7 times. Now we are going to calculate our probabilities. A very simple but very effective equation. How does it go? Well, we take the number of times that we've thrown a move, divided by the total number of games. So for rock, 8 over 20, which gives us 0.4. How much percentage is that, Alex?
You multiply by 100 and you get 40%.
Indeed. So now we're starting to see some clear results. Alex threw the most rock and the least paper, and scissors was kind of in the middle. So, with 40% rock, that tells me quite a lot about Alex's strategy during the game. Alright, Alex, we have some pretty cool results, but what we have to remember is that those results only apply to the 20 rounds of games that we played, and those are not enough in order for us to make predictable, reliable decisions. Okay, so in theory, all gestures still have an equal chance of occurring and winning. 1 in 3, it's random. So, but why did then some of the gestures occur more frequently than others, like for example rock? It is actually because of the behavior and the choices of your opponent. And this is where Chinese researchers did a really cool study. They recruited 360 students to play the game 300 times for a whopping 2 hours. What they found? Indeed, players choose their moves completely randomly to confuse their opponent. The chances remain 1 in 3 for each move, but they did discover a hidden pattern, which was that winners showed a very high chance of actually repeating the same move in the next round, and losers did the opposite. They had a very high chance of actually switching their move for the next round. So that is a hidden statistical probability pattern that tells us a lot about how we could win the game.
That's so interesting, because it actually goes to show that when you have many examples, you can detect big patterns, and then you can make better choices based on those patterns.
Exactly.
Super cool. Next up, we have a very cool experiment to show you how patterns, how probability can help predict patterns, and you can see order out of chaos. Excited.
We are ready to test our probability machine. All we need to do is take a ball, drop it in the top, see it bounce off the nails before it finally drops into one of the slots or categories at the bottom. Our board is a visual investigation on the probability of where our balls will fall. Every time a ball hits a nail, there is, in theory, a 50-50 chance of it to fall either on the left or the right side of the nail. So each path is pretty much unpredictable. Even if we take 2 balls and drop them in at the same time, they will still end up in completely different positions. We can't possibly accurately predict where a ball will end up. But we can make a few statements. A ball is more likely to end up in the middle because in the triangle center there are lots more paths it can take. There are only a few paths on the right and the left side of the triangle for the ball to end up on the outer slots. So what we can do now is to test actually with loads of balls. Even if we can't predict where the individual balls will end up, we can predict an overall pattern from lots of them. So let's see what results we can get. Okay, we can now see a clear visual pattern. It is famously called the normal distribution, with few balls on the sides and many in the middle. Many things in life and nature follow exactly this pattern. People's heights, shoe sizes, IQs, income, student grades, even the weather. A lot of things in science, math, and engineering match this pattern. A bell-shaped curve. Our experiment shows us we can't make good conclusions about one or few balls, but we can say a lot about the behavior of many. So, our experiments show us that actually math, statistics, probabilities, essentially data and information let us see the world in a whole new way. They let us see the big pictures, the big patterns that help us make decisions that benefit us all as a community.
So with all of that innovative thinking said, we can't wait to see you on the next episode of Science You Had Me At Hello!